So I heard that many projects rely on data source that is not necessarily locally in a local cluster. So they need to stream data from remote clusters in order to run processing. So that's what we are proposing here is in this project is basically an optimization for workflows that are relying on data transfer, wide area data transfers in specific. So I will just repeat what, I mean, probably most of you guys already know is that the many science projects are distributed in nature. They gather the data from a single observatory and move it to different clusters to process it, and which requires data to be fetched from a remote cluster and be processed in a timely manner. Another part of the motivation is that scientists share data, right, in order to enable the collaboration. And the third motivation is that even if you don't process the streaming data, sometimes data is being stored in a central repositories where you need to download it and process it in order to run your computation. For example, NCBI is one of those databases where you can download large volume of the RNA or DNA sequences and run processing. And actually we have use case in here at University of Nevada, Reno, that I know that at least one researcher is doing this, and they are mentioning that this is kind of a painful for them because they it's a large volume of data, and just moving the data from NCBI to local cluster before starting the process is taking a lot of time. So what we are proposing here basically, so there are, yes, if your workflow relies on remote data sets, then you have a couple of options to execute your framework. Basically two main options. One of them is that you can download the data first and start the processing later, which is, I think, most common approach where, let's say I'm gonna process this 100 gigabyte of data set. Let me download it to, let's say, stretch file system or local storage of the compute server, then you can start the processing. But this is, as you may imagine, not an optimal way because then you have to wait for your transfer to complete before actually you can start the processing. So you basically, if you're already reserved your compute power, then you are basically wasting your time. And the second option is that, okay, let's assume that we have a stretch file system, then we don't have to reserve the computation until the data downloading is completed, which is another option, but still you need a large staging space, which may not always be possible to do. For example, if you need to download 1 terabyte of data for processing, and your stretch space or your temporary space staging space may not be that much. And in some clusters, such as the ones that we have at UNR, is charging you based on your maximum storage usage. So we don't have stretch space that we can stage data. So basically you have to purchase space in order to keep your files. So it is, let's say, assume again, you need to process 10 terabytes of data, but you're not gonna utilize them, you're not gonna save them. You need to basically pay for that 10 gigabytes for an entire month, even if you are just gonna use it for 1 day. So because of those reasons, this is the download first and the process later approach is not necessarily the optimal way of running distributed workflows. The second approach is streamlining the computation and transfer operations, which means that you can start your processing, and as you get the files, assuming that you don't need all the files to start your processing, you can just download the portion of it and start processing. And as you make a progress, you can basically download more files and process them, so that you don't necessarily need to wait for an entire dataset to be staged in before you run your processing. But this is also has some challenges that needs to be tackled. One of them is that how are you going to make sure that your computation and the communication speeds are matching, right? Because you're gonna download data and the process later. You need to make sure that you're fetching the data fast enough and you're processing them fast enough as well, right? So if you're, let's say, have allocated the compute power that can process 1 gigabyte per second, if your transfer speed is not that fast, then you're basically going to end up wasting your computation power. So what we want to make sure that the computation and the communication can go hand in hand, that they can work in parallel, and they can basically provide the maximum utilization that you can get from that resources. And even if you, let's say, assume that you configured your system that works fine, you configured your transfer settings, and you assume that things are working fine, there is always the possibility of interference, right? Resource interference. It could be computation interference or network interference that will affect the performance of your computation power as well as the communication network transfer speed. So because of those reasons, you need something that is adaptive, that can dynamically change or tune the transfer or computation in order to make sure that your computation and communication can go at the same speed to maximize your workflow scheduling and execution. So yes, we are proposing an optimization for the second approach because the first approach is apparently more time consuming. So we believe that the second approach is optimal, but we also think that we don't have resources or that that is gonna make sure that the second approach is working as expected. So what we are proposing in this architecture is that, so we like to rely on the Parcel because the Parcel is a workflow manager that can schedule and basically grow your computation power in an adaptive manner, right? It provides adaptive, it supports elastic scheduling where you can grow your computation power as you need. But what we don't have is the transfer manager that may grow the speed of the transfer, that can basically be dynamic and adapt to the speed of the transfer to the speed of the computation. So what we want is basically a mechanism where workflow managers can send signals to the transfer manager saying that, okay, I'm able to process the files at the 2 gigabit per second speed. Can you make sure that you can get that amount of network transfer, network throughput to make sure that we don't waste any resource at all? And there are several ways we can do that. I mean, if your network bandwidth is limited and you're already hitting that limit, then there is not really nothing else to do. I mean, because it is what it is. Like, I mean, we cannot go beyond what resources allow. But most of the time, that is not the case. The case is that your transfer algorithm is not necessarily optimal, and it doesn't necessarily provide you the maximum the throughput that you can get. So what we propose is basic adaptive parallelism. Instead of like using one transferring one file at a time, you can transfer multiple files at a time in order to improve your transfer speed, for example. So we are trying to or proposing to integrate the HARP, which is a data transfer algorithm that can provide high throughput. It is also responsive to the changing conditions. If your network traffic increases, then HARP can take some steps to try to mitigate or alleviate the impact of the interference. And it can also support the integrity verification that is scalable. So integrity verification is something that you want to make sure that your data, your files are not corrupted when you are transferring them, and that can significantly impact the throughput of your transfer. So we also, the HARP also supports integrity verification that can be dynamic. Basically, it can utilize more cores in order to make sure that the speed of the integrity verification matches with the speed of the transfer. So yes, I'll just have I think one more slide. Sorry, I'll try to wrap it up as soon as possible. So this is the architecture that I'm not going to go into detail, but what the Parcel provides already is elastic scheduling. And what we are proposing here is basically elastic scheduling for data transfer, and we'll try to integrate. in the process of integrating HARP to parcel by trying to achieve some communication between them. And the parcel will try to get the metrics from the parcel in terms of how fast we are able to process the data, so that we can use that information to adjust the network parallels. So why parcel? So parcel supports computation parallelism. So our overarching goal is to have the end-to-end parallelism. So we are going to propose network parallelism with HARP, but parcel also supports computation parallelism. So if we can integrate them together, then it will be a great way to provide end-to-end parallelism. It is easy to integrate. Actually, we find it really, convenient and really easy to create a new data transfer module in Parcel by just implementing a couple of functions. And we got really good help from the development team. So we are really, happy that it's also, good and in terms of not only easy to develop, but easy to get help. So because of those reasons, we decided to use Parcel. So that's basically it. Thanks.
All right. Thank you so much, Engin. I guess now we're running a little behind, but we'll open it up for some quick questions. Does anybody have anything?
Yeah, very quickly, I think there's a lot of interesting use cases that ask for this type of thing. So I saw pictures there of like LSST and stuff. I think any instrument science would be useful for this, right? Like APS and stuff, where you're streaming data off instruments and wanting to process quickly.
Correct. Yes. Yeah. This can be not only it can be applied to downloading a large volume of data from a repository, or it can be used for streaming transfers where you're collecting your data in a streaming manner. So it might be the case that your data may not be available all at once. So it might come from observatory that over a time. So that might be, you're right. It could be helpful in those scenarios as well.
Yeah, very cool. And I assume when you said implementing the modules, the parcel data management interface, you're basically using the plugin there, are you?
Exactly right. Yeah, I think we find we could implement it in a week. This there are a couple of functions that